Hey, welcome to the latest RC Crew Chief screencast. This one is going to deal with the new version that was just released that deals with simulating nitro motors. So first thing we got to do is we've got to hook up a car to a nitro motor. So you can see here we have two buttons, radio buttons below the nitro or the motor manager now, one for electric, one for nitro. Right now this is selected the electric one because that's what's been attached to this car. So let's pull up a nitro car. The Capricorn C801 is one, and we're going to hook up a nitro motor to this. Right now, the first time you open this and set this up for a car, it will probably be set to electric. So all you have to do is click on the nitro button and then select one of the motors from the list. Right now there's only 4 motors on the list. I'm hoping to expand this in the near future, and you will be able to download more motor dyno curves from the website. So let's select the Pico 21 size motor here. That's a typical motor that would be used with this type of car, and just click save. Close it out. And so now you see we've got the Capricorn and we've got a nitro motor selected, and the nitro button is selected. If for some reason you may want to just go and edit an electric motor, you can click on this and that would open up the nitro or the electric motor manager, but we're not dealing with electric here. Let's deal with nitro. So let's open up the nitro motor manager and see what we've got here. So again, the motor that we have attached to the car is selected for us. We still have these other motors here that we could look at and edit, but we're going to stick with the one we've got assigned here right now. The other thing that you have to do in the nitro manager is to select the gearing that your car uses. So if it's a single speed, you only enter obviously first gear, and you would just blank out second and third. In this case, this has a 2-speed transmission, so these are the values that are typical for the Capricorn C801 2-speed transmission. The other thing we've got here is a shift RPM, so this is how high the RPM would run before switching over into second gear. The other thing is a shift time. Now this is the time that takes the motor to shift from first to second gear. So during that 100 millisecond time that I have set here, the motor would transition from the RPM that it reached in first gear when it shifted to the RPM that it will ultimately start out at in second gear. So during that period, the motor RPM is changing and the transmission is shifting from first to second gear. At no time during that period is the torque disconnected from the motor or from the drivetrain. These types of transmissions, you're generally always on power, so you're not going to see the torque drop to 0 as you would if you were driving a normal car where you would push a clutch in, disengage the transmission from the motor, shift to the next gear, and then re-engage the clutch again. So that's those are some of the parameters you need to enter there. And then the other thing is obviously we need a dyno curve. So all you have to do is enter in the RPM and the torque at that particular RPM for as many points as you want. A 1000 RPM increment works fairly well. What the program does is it interpolates in between these values. So if the simulation reaches, let's say, 21,200 RPM, what it would do is it would look in between these two numbers and figure out an appropriate torque value to use, somewhere between 45 and 46 ounce-inches in this case. So here we have the, for this motor, this is the torque and power curve. You can click on it, get a little bigger view. So the torque curve is here. The power is calculated from the torque curve. You don't have to enter power numbers. You just enter the torque values, and the program calculates what the horsepower is based on the torque and the RPM. So the other thing that we can do here is we can look at, we can compare two motors. So we've got two selection boxes here. When you open it initially, it'll be set to the whatever's on the main page. So we've got our Pico 21, and let's look at the difference if we go to a mod motor. So the mod motor is one that was modified by AB Mods, one of your engine tuners who can work wonders with these little motors. So you can see here there's a significant difference between these two motors, exactly the same, just with the tuning. I'm not even sure exactly what they do, ports and all kinds of other good, wonderful things. But you can see here we've got a power increase of 2.12 was the stock motor and 2.36. So we got 0.2, almost a quarter horsepower more with the tuned motor versus, or the modified motor versus the stock motor that you would receive from the factory. And similarly, the torque has gone up by about 10% as well. So these are definitely not insignificant changes. This is a fairly substantial improvement in the performance of these motors. So we could also look at, if you wanted to see what the difference between a 21 and a 12 size motor is, we could also look at that. I don't know why you would do that, but anyways, there you can see that there's the significant difference in the performance of those two motors. So that's the motor manager. Now once we've got our car and motor hooked up, now we can look at doing some acceleration runs. So if you click on this, it'll take a second to run because it's actually running the simulation before it switches into the tab. So here we have the acceleration page, which is very similar to the previous one that some of you may have used before. But now we have the ability to look at nitro motors. So we have the same interface. We have two different cars here that we can set up differently, and we can look at the acceleration and speed versus time characteristics of the two motors and change all these parameters and see what the effect is. So first off, let's just do what we were just doing, comparing motors. Let's just switch to our modified motor for the second car. The first car will always be hooked up to the car that you have selected. You can't change it there, but you can change shift RPM delay and all the other parameters that go along with that. So we've got our Pico 21 mod motor here. So let's just click on calculate and see what happens. So there you go. So there is the difference between the two. If we want to just look at speed, you can see here that the should point out here, if you click on any one of these four graphs, let me just close this out, click on any one of these four graphs, it will bring up a larger version. So there's the torque, there's distance traveled, and there's speed. So you can see here that the second motor, the mod motor, has attained a significantly higher end speed. We're probably looking at about 65 miles an hour here versus 61.5, something in that order. So 62 maybe. So you've got quite an improvement in speed. The other thing that you've got is, because you got more speed, you got more distance. So there's a nice little summary here that shows you what the difference between the two motors is. So car 1 at the end of a 2-second full throttle run would have gone 143 feet, whereas car 2 would have gone 148 feet. So you've got about a 5-foot difference between those two cars, which at the end of a 140-foot long straightaway is a pretty nice little advantage to have over your competitors. So there you go. You can see the difference right there with just changing the motor. We haven't done anything to gearing or shift delay or anything of that nature. While I'm here, I'm going to quickly look at the shift delay. I don't want to use up too much time here because you guys want to be able to play with this thing too. So let's just look in here. So this is your shift delay. The shift delay is the time here where we reached our 36,000 RPM and the motor or the transmission is now shifting between first and second gear. So the shift delay is this time here from there to there. Right now both these motors are set to 100 milliseconds. So let's change our hot motor here to 50 milliseconds and recalculate that, and you'll see what the difference is in that transition. So now you can see that motor 2 is transitioning significantly faster between the 36,000 RPM and the 29,000 RPM that it starts out at in second gear, whereas this one now is still at 100 milliseconds. So this time, and it doesn't make an enormous difference in the end speed, so you can play with that if you want to see what the effect is, but it's not a huge change. You can change your, if you want to change your gearing, we can go through and we can change all those values as well. So that, in a quick nutshell, is the new version. Just go in and play. Well, the other thing I should probably talk about here is there's a little change to the aero constants. Unfortunately, I've searched high and low, but cannot find any good hard data on aero drag or downforce coefficients for our little scale cars. Tried to talk to some of the body manufacturers, but got no response. So what I've done here is, these are based on what I've been able to find online, are sort of in the range kind of numbers. So what I've done is, there's 3 different body areas in here. There's 1/10, 190 touring, 200 touring, and 1/8 on road. So just selecting one of these will change the areas that the car has, the chassis or the body has. Then you can also use a low, medium, or high drag value, and that changes the drag coefficient. And similarly for downforce, that changes the what's called the lift coefficient, but in our case it's actually a downforce because we don't want lift. So anyways, that's something you can change these numbers. If you do find some good information, first thing, tell me, but you can change these values to whatever you want to use, and then just click apply. So you can click apply, then it's going to rerun the simulation based on the new values that I just entered. Okay, that is it for now. Enjoy.